Hello students, I am Hasina Bibi, Assistant Professor CSE Department, Rohini College of Engineering and Technology. And I am going to present on topic from the first unit of operating systems. The topic is interrupts. And the objectives of studying this topic is to understand the use of interrupts and to analyze the interrupt handling in operating systems, to understand how the interrupts are handled in CPU. Let us start with the introduction about the interrupts. Interrupt is a signal that prompts the OS to stop one process and start work on another process. Normally, interrupt is a mechanism by which any input-output device can interrupt the processor so as to divert the execution of the CPU to execute the device code. Okay, whenever the device, any input-output device wants to execute its operation, it will intimate the CPU by sending the interrupt signal. This signal is called as interrupt request signal. So the CPU will be performing its normal execution as per the scheduling of operating system. Whenever the CPU noticed the interrupt coming from the one particular device, it will decide whether to process the interrupt or not. When the CPU decides to process the interrupt, it will send the acknowledgement signal to the device that sends the interrupt. And after that, the CPU will stop the current execution of the program, and the execution control will goes to the interrupt program. That is, the code corresponds to the interrupt, and the CPU will execute that code. That code is called as interrupt service routine or the interrupt routine. So the interrupt routine is the code corresponds to the interrupt. That is the code to process the particular device. So only the device sending the interrupt to the CPU. So after completing the interrupt execution, the CPU's control will comes back to the old process execution, and the old process execution will be resumed. So this is the normal sequence of operation happened during the interruption. And normally the interrupts may be provided by the software or hardware. So the interrupts are classified into hardware interrupts and software interrupts. For example, program is the software interrupt. Programs may interrupt the execution due to some situations like arithmetic overflow, division by zero, attempt to execute an illegal instruction. So due to these situations, the software interrupts will be triggered to the CPU. And the timer is the hardware interrupt. In the real-time systems, the end of one particular operation will be intimated by the timer signal. So the timer interrupt is used to intimate the end of some timing, end of the operation. And the input-output devices may interrupt the CPU. This is the normal case which I told previously. Input-output devices will interrupt the CPU and to get the service of the CPU for its operation. And the hardware failure, due to some hardware failures like power failure or memory parity error, the CPU will be interrupted. And now we are going to see one diagram here. The user program will be executed, and in between the user programs, the input-output operations are performed by the CPU by executing some write system calls. Write system calls are called by the operating system to execute the input-output commands for the input-output programs. So during the execution of the input-output programs, the user program will go to the waiting state. After the completion of the input-output commands, the user programs will be resumed. Okay. So this is normally happened without the occurrence of interrupt. So without the use of interrupts, once the input-output command is issued, the program must wait for the the user program must wait for the input-output device to perform the requested function. and the dashed line represent the path of execution. In the diagram, the dashed lines represent the path of execution. Sometimes the normal execution will be takes place, that is the user program execution, and as a result of system calls, the input output program execution will be performed. After the input output program execution is completed, the execution resumes in the user program immediately following the write instruction. So the input output operation may take a long time to complete, so that the input output program hang up waiting for the operation to complete. So at that time the user program is stopped at the point of write call, and the user program will be waiting for the completion of input output operation. Okay. So with the interrupts, the processor can be engaged in executing other instructions while an input output operation is in progress. So the user program reaches a point at which it makes the system call during the write call. The input output program that is invoked in the case consists only of the preparation code and the actual input output command. So as a result of interrupt, the external device becomes ready to be serviced. External device means that is the source of interrupt, and when the CPU decides to execute the interrupt, and it will check for the device whether it is ready to accept the data from the processor, and the processor will be executing the interrupts as a result of the interrupt request from the device, and the processor responds to the interrupt request by suspending the operation of the current program, and it will execute the interrupt routine. Now we are seeing it with the diagram. The user program is there. The user program consists of set of instructions, and the CPU and the processor will be executing the instructions one by one. When the interrupt triggers to the CPU, when any one device sending the interrupt request, the normal current execution will be stopped, and the execution control of the CPU will goes to serve to the particular device, and the corresponding interrupt handler will be executed by the CPU. After the completion of the execution of the interrupt handler, the execution control comes back to the previous portion of the user program. So the CPU will resume the execution of the user program. And now we are going to see the operations performed by the hardware and software during the interrupt processing. So as we told, whenever the CPU notifies the interrupt, some operations, some status storing and restoring will be happening in the CPU. The device controller or the other system hardware issues the interrupt. Device controller means it is present in the input output devices. The device controller will present in the input output devices only, will send the interrupts to the CPU. Okay. So we know that the CPU will execute the instructions one by one. Okay. So when the processor completes the current instruction execution, it will check for the pending interrupts. If any interrupts arrives to the processor, if it decides to respond to the particular interrupt, the processor will send the acknowledgement to that interrupt. That is, send the acknowledgement signal to the device that sends the interrupt. Now what will happen is the current program execution will be suspended, isn't it? So sometimes the program execution is stopped in the 50%, means the current execution details or the current execution status will be stored into one register called as PSW, program status value. That is the current value of the PC. The execution control is now going to be changed to the interrupt now. So the previous user program execution is going to be stopped, going to be interrupted. So up to the current execution, the current value of the PC and the current execution status of the user program will be stored into the PSW register. What is the need of storing this is, when the CPU comes back after the completion of the interrupt, it is enough to continue the remaining execution of the old process. No need to start the execution from the starting stage. It is enough to continue the remaining execution. For that, whenever the user program or the old program is interrupted, the current details of the execution or the intermediate results will be stored into the PSW, and the current PC value will be stored into the stack memory. And after that, all the registers present in the processor will be now using for the interrupt execution. Now the processor is going to execute the interrupt now. So the process registers available in the processor will be loading with the interrupt details now. So the PC will show the address of the, now the PC value will show the starting address of the interrupt routine. So at the same time, the software will do the operations like, software will save the remainder of the process state information, and it will go to process the interrupt execution. And after the completion of the interrupt execution, it will, the process state and the information previously stored into the PSW for the old process will be restored into the corresponding registers to resume the execution of the old process. So the PSW and the PC value will be resumed. Now the processor will resume the old execution, and the old user process will be, execution will be completed. Okay. Now normally we have seen the instruction execution will have two cycles, fetch cycle and execute cycle. But to accommodate the interrupts, one more stage, one more cycle will be added to the instruction cycle, that is interrupt stage. So we all know, during the execution of each instruction, instructions will be fetched from the memory in the fetch cycle, and it will be executed in the execute cycle. Execute means the instruction will be decoded and the operation mentioned in the instruction will be performed by the processor. But to add the interrupt operation, interrupt stage will be added. So during the execution of the current instruction, the interrupts will be disabled, and when the processor complete the execution of the current instruction, the interrupts will be enabled, and the CPU will checking for the pending interrupts. It will check whether any interrupts have came from any device or not. Okay, after in every execution, after the completion of every instruction execution, the CPU will check for the pending interrupts. It will check for whether any interrupts have came from any input-output devices. If any interrupts came, means the current program execution will be stopped, and the CPU execution control will go to the interrupt execution, isn't it? So for that, one more stage, interrupt stage, is added to the current normal execution. That is, along with the fetch stage, execute stage, interrupt stage will be added. So the interrupt execution is based on some priority levels or based on some preferences. Not all the interrupts are processed by the CPU immediately. Based upon the necessity of the interrupt only, the CPU will decide whether to stop the current execution or whether to execute the interrupt. Okay, based upon the necessity of the interrupt, the CPU will decide the execution of the interrupt processing. Okay. Now let us see the possible university questions in this topic. What is meant by interrupt mechanism? How the interrupts are processed? Explain the instruction cycle with interrupts. Okay, thank you all.